Hello, thanks for tuning in today. So I am going to share with you a question, some common questions selectively from common topics that you're going to get for your end of year exam. Yeah, and here we go. So today we're going to cover one question on quadratic equation. All right, so if you are having difficulties with this question, with this kind of issue, particularly focus on completing the square as well as how does it relate to the graph. Okay, so the second one is if you have a factorized form for quadratic equation, then when you sketch the graph, what are the things that you have to look out for? Yeah, so here we go. So question one here says that we have a equation, all right? It's quadratic equation because the highest degree here is the x squared, right? And you want to put it in a form of a perfect square like that, right? In which that they say a and b are integers. So this, whenever you see that the format is becoming like that, it must be a perfect, completing the square method, yeah? So we are going to basically, whenever you do complete the square method, one of the things to look out for, number one, is to remove the coefficient of the x squared. So make sure that the x squared doesn't have any coefficient. That's step number one, right? So in this case, we have a negative that you have to factorize out of the expression. The whole equation has to take out a negative one so that we can remove the coefficient. But take note that because there is no value here, that you cannot basically solve for x, so you can't just divide by negative one. You can only factorize it. Okay, so the factorize is the only way to go when you do complete the square. So take note that if you take out a negative one, you are dividing all the terms by negative one, which is why all of their signs will reverse. Then after this step, then you can do the complete the square method. Now for the complete the square method, remember that we are trying to make it one of the two special products that we have learned before in Sec 2. These are the two. So you either change it into something like an a plus b bracket square, which means that if you take the raw form, this is what you have in the expanded for the first special product. And for the second one, when you expand it out, this is the three terms that you will get, right? So how would you know which one is to be used? First of all, like I said, you must make sure that the coefficient of the x squared is being removed so that that will represent the a, all right? And then this term here that has x, right? It's going to be basically a 2ab, or rather, if x is a, then your 6, the coefficient of the x, right, is basically 2b. And of course, at the same time, you're also going to take into account the negative sign in front. And this negative sign attached to the negative, the 6x, right, will tell you that this is actually the second special product because only the second special product will have a negative 2ab, right? And for this method to work, just remember that you cannot, you have to ignore the plus 4. So what you do is you basically collect the square root of x squared to get x, and the half of the coefficient of the x. That means you have to use 6 to divide by 2. And inside the bracket, it should be a negative sign because again, it follows the negative 2ab, which should be the second special product, right? So 6 divided by 2, you get 3. Don't forget the bracket square. Now, what you have just done is to force the first two terms here to become a special product. And if you have done so, what you are basically doing is you are making b square appears on the right side, which originally it does not have. Remember, the 4 is not part of the special product. It is just something that you have to ignore. So that is not within the special product. Okay, got it? And again, if you throw it this negative 3 in, if you make it become special product, you have created an extra b square that originally it does not have. So what you need to do next is to minus away a b square on the outside, all right, which is 3 square, right? And don't forget also that there is a positive 4 that is being left behind. That cannot be removed. And because the whole thing here is part of a negative expression, so we put one more bracket to enclose all of them. So let's simplify the inside. You would have minus 9 plus 4. it will be negative 5, right? And then finally, because we still have this overall negative expression for the whole group, so we got to multiply it in again. So the negative times the x minus 3 bracket square, and then negative times negative 5 becomes a positive 5. And we arrange them in the same format as what the question was, which means that 5 goes to the front and the negative bracket x minus 3 square is put behind. Okay, and there you go. So both of these numbers a and b, they are integers which accepts, which basically the condition, we fulfill the condition of what the question wants. Then after that, this is not done yet. We have to sketch the curve, right? Now take note that for sketching of a curve, if your first thing that you obtain is the complete the square, your first information that you should obtain out of it is actually the turning point. I say again, if you get the complete the square method done, you should get the first information out, which is your turning point. And of course, one thing to take note is that it has a negative x squared, which means that this is going to be a frown curve, right? The negative coefficient of the x squared will determine whether it's a smile or a frown, right? If it's a positive x squared, then of course you have a smile. So in this case, it's a frown, which means that the turning point is referring to the maximum point. I say again, the turning point is referring to the maximum point because this is a frown. You will have a highest point that the graph cannot be bigger than that. So for this, how to get the turning point is to make this part, the entire bracket become 0. Now, reason why this is 0 is because, now imagine that you throw in any number that is higher than 0, right? So something like 2 minus 3. What I mean is, if you make this overall group becomes a number that's more than 0, the whole bracket, if it becomes a number that's more than 0, you will have something like 1 square or 2 square or 3 square. And you will find that the 5 have to subtract a number that's getting bigger and bigger, right? In fact, you got a minus. If you go all the way to infinity here, you have to use a 5 minus a super large number, which will result in a very small negative value. So this means that there is no limit to the bottom side, right? Because you can keep on subtracting as big a number as you want to make it as an overall negative result. But there is a cap in the positive side, because if you want it to be the maximum possible, then you got to make this group, entire group, become 0, right? Which means that x minus 3 is 0. So x is 3. Now, and if this entire group is 0, and then you will have 5 minus 0 as the outcome for y, right? So y will be 5. So the turning point is 3, 5. Now, why do you need to list this out before you draw the curve? Is because you want to be able to understand all these different numbers first. You got to plan ahead before you draw, right? Even though it's just a sketch. But the examiner will be particularly looking out for the turning point, that's number one. And the second thing they will be always looking out for is the y-intercept. These two are a must to have, okay? So for the y-intercept, take note that when it cuts the y-axis, the x is 0. Remember that? If it's any number found on the y-axis, x is 0. So you are substituting x equals to 0 into the equation to solve for what will the y value be when it cuts the y-axis. All right, so this means that the y-intercept is basically 0, 2. Now, this question didn't say that you have to show the x-intercept. They didn't state in the equation here. So this would mean that the only ones you need to have is turning point and y-intercept. Okay, so x-intercept is an optional one, depending if the question asks for it or not. Yeah? So this is how you get a mark. All right, so once you have the maximum point as well as you mark the y-intercept, you can then begin to draw this graph. Right, remember it's just a shape of a frown. And there we go. We got the sketch. I think we didn't label question A for this one. Yeah, sorry about that. All right, and then also another thing that the students tend to forget after a while, especially when you move to Sec 3 and Sec 4, you can't escape this question. It's one of the very common questions that they like to come up with at least 1 or 2 times. All right, the line of symmetry, basically the line in the middle that causes this graph to be a mirror image, and that line is usually cutting through the turning point, a vertical line that cuts through the turning point. So which means that it has the same what value? It has the same x value as the turning point as well. And for any vertical line where it always cuts the x-axis, you can see that no matter which point you are talking about, this x value, the x coordinate doesn't change. Which is why for all vertical lines, the equation name will be x equals to that number that it cuts through the x-axis, right? In this case, it cuts through 3, so x is equal to 3 is your answer. All right, stay tuned for the next one. We will have share with you a second question. When you sketch a graph, provided that they give you a different form, a factorized form. So look forward to it.